Welcome to today's tutorial. We'll be continuing where we left off. So let me open my Eclipse. So let's open the project and continue. So Eclipse, then it's loading. And then I also need to open draw.io so that it's easier to come up with the code when you can visualize the solution. So I'm going to open an existing diagram. It should be somewhere here. So there is the diagram that we created in our previous tutorial. So the diagram is there. So let me zoom out a bit. So there's the diagram, and then let me open the question paper. So there we go. So there's the question paper. We don't really need it because most of the things that we need are in the solution or in the code provided. So let's continue. So I'm gonna go back to the dlist class. So we last we left with the implementation of the node class and all of the accessors and getters for every instance variable. And we also created the toString method. So let's continue implementing. So the question is, how do we implement the constructor, where the constructor takes in a list or an array, right? And then you need to convert that array into a D list, right? So what I need to do is I need to start by, before I do anything, right? I need to start by initializing these nodes, right? Or basically creating an empty D list. So I can do that by calling another constructor, which is the parameterless constructor. Okay, so let's continue. So I'm gonna create or instantiate the instance variables, which is the header, the trailer, and the size. Even though they already initialized, but then I need to set their pointers, right? Just like they did here. So I need to call this other constructor. So how do I do that? So I need to call. So let me delete this code, this comment. So call the parameterless constructor because we need to create the pointers. I could do it manually, right? By creating these pointers manually, but there's no need for that because I already have another constructor. So if you remember in Java, right, second year, the way you call a constructor within that class is by using this keyword followed by round brackets or parentheses. And then if you're calling a parameterized constructor, then you pass in the parameters. In my case, I'm calling this constructor over here. So that after calling that constructor, the parameterless constructor, now I've created an empty doubly linked list. So I currently have this scenario at the moment. So which is an empty um, doubly linked list. So let me zoom in, maximize. So there's the doubly linked list, an empty one, right? Which only has a head and a tail. So now we need to insert. So or how, we need to create a linked list from that, right? A linked list from the array, a doubly linked list. So how do we do that? How do we create the doubly linked list? So to create the doubly linked list, we would have to change the pointers, right? So we'd have to change our pointers. But then before we get to that, very useful function here, which is the add last method. So the add last method, the way it works, right, is that it adds that node, it adds it to the it adds the new node to the end, meaning it adds it right before the trailer. And this will become very useful because let me demonstrate it. This will become very useful because in our case, we really need that method. So I'll show you why by deleting this. Also delete this link, and then I'm going to create a null there. So there's the null, and then I'm going to set, we've already done this, right? What I'm doing right now. We already did this using the parameterless constructor. And why is it being stubborn? So there it is. And then the value is also null. And then next should point to the next node or the first node. But we need to insert the new node right before the tail. So let's say we're inserting a node right before the tail. It means that it comes just right before the tail. And then if we insert another one, so I want you to sort of like get a picture of how the diagram is going to look. So I'm going to select everything and then shift it to the right, and then shift this, then shift the tail, the text. So if we add the node, if you call the add last method, it's going to add the node right before the tail, which is very which is going to become very useful because we're going to be able to add our values in the same order in which we receive them. So for example, if I get the first node, the first value from the array, it will actually become the first node because this linked list, doubly linked list was still empty. And then I get the second value or the second value, and then I add it right before the tail. So as you can see, we start achieving sort of like an array. So we're gonna put them in the right order in which we got the values from the array. We're gonna have the same order. So that's why I'm gonna use the add last method. So let me put them a bit up. So after adding this first node, it's gonna be like this. Next is gonna point to it. Then its next is gonna point to the tail, and then the tail's previous is now gonna point to that new node. Then if we insert a new one, remember add last, it adds it right before the tail. So that means it's gonna come after the first node. So it's gonna be like this. And then we update our pointers as usual. And then if you add another one, it's the same thing. It comes after this one. So you see that if I have values like, if let's say my array is like 1, 2, 3, 4, and I want to create a new node which has a value of 1. When I insert that new node which has a value of 1, it's gonna become the first node, of which that's good because in the array it was also the first value. And then if I want to insert 2 or a node with the value 2, it's going to be inserted right before the tail, which means it's going to be after the first node, which is 1. So it's going to come after 1, which is exactly what we want for it to look like the array, meaning it's going to be in the exact same order. So this function add last is going to become very useful. We don't have to worry about add before and add after these nodes. We don't have to worry about them yet because we will implement them when we get there. Just assume that add last and add first and add last functions, they're already implemented, just of which they are, but then they call methods that are not already implemented. But just assume for now everything works. So we're gonna use the add last method as if it already works. So after calling the constructor, we need to iterate through our array. So I need to go through the from array. So what I'm going to do is, you don't have to do this, but I'm gonna get the length of the array. right? So int length is equals to from array dot length, right? So I've stored the length of the array. Then now I iterate, or I go through. Another word for iterate is to go through. It means to go through the array. So I'm going to iterate the array or go through the array. So you need a for loop for that, right? As usual, just normal stuff, right? So int I is equals to 0, I is less than length, and then I plus plus. And then there's my for loop. So you might ask yourself, well, what is the whole significance of you creating a separate variable for length? Well, it saves computation, right? It saves the computational time, right? Meaning that it's going to be a bit faster compared to me calling it here. Because remember how the for loop works. It has the initialization statement, which is executed once, right? So that'll be an O of one operation plus this section over here, which is executed as many number of times as the actual length of the array. So which is going to be O of n. If remember, n represents the input size, meaning how many things or how many values are in the array. That's what n represent. If we have 4 values in the array, so n would be 4 in that scenario. Plus big O of what is how many times will the statement execute? It's going to also execute O of n times, because every time after the loop that statement is done executing, it's going to go back and increment that loop variable by 1, and then it checks if that 1 is still indeed within the right range. If it is, then it continues. So as you can see, it's going to keep running this section here and keep on incrementing as long as this is true, right? So that means this will also run an O of n time. So with that being said, that means that we need to find a way to save time when it's comparing. Because remember, when it's comparing, if I put it back to the way you're used to, if I say from array.length, it means that before the check is done, it's going to execute this dot operator, meaning it's going to go and calculate. And in order to find the length, in order for it to find the length, it has to execute or we're calling the okay. So this is it's not a huge change. To be honest, you don't have to necessarily do this, but for the sake of saving time, because this is an operation on its own, right? The dot it's an operation on its own. So that will also take time. So it's better to do it once outside the loop so that we save time and don't keep doing that same execution. This dot operator will execute, right? So in order to save a bit of time, I'll let it run once outside the loop, then we just use that answer. So that means we're only going to do the comparison. We don't have to do the accessing first, then compare. So instead of doing 2 operations, now we're only going to do only one. So it's going to save us a lot of time. So there's our array, right? There's our array. All right, so our array, in order for us to add a new node, if you look at the add last, let's look at add last. So add last, it expects you to put in an item, right? Meaning a value. So to be honest, this is gonna become actually very easy, because with add last, we don't actually have to create a new node, right? So we just need to pass in the value. So I just call the add last method, and then I use the array name, and then I index into the array, and then done. So I've added the nodes. So now the nodes will be linked, because if you remember the diagram that I was demonstrating, if you call add last, it always adds it before the tail. So if you add 1, so let's say this is a node with the value 1, right? So this will be the first node. Imagine this one is not there. right? This one is not there. I didn't copy everything properly. So imagine this one is not there. So we'll have our links there and then links and everything. So this will be the only node. If I call add last again, it's going to add it right before the tail, meaning it comes after this first node. So which is exactly what I want to achieve. I want to put them in the exact order in which we found it, or in which we found them, the values in the array. So that's why add last is going to become a very useful function to achieve that. It's going to keep adding it on the last. So it's like a queue. For example, if you're going to withdraw money or the pick and pay queue, you're always going to go to the end of the queue, right? So which means that you're going to be arranged in the same order in which you came in. So which is exactly what we're going to achieve by doing this. So this is how I would implement this constructor. It's pretty straightforward. So let's see how much it has, how many marks it has. 5 marks, not too bad. So that's 5 marks. So we scroll down. So that's pretty much all we had to do. And remember, you might ask yourself, okay, what about change? Remember, we're adding nodes. Why are we not updating the size and stuff? Well, if you look at the add last and add first method, right? The core methods called add after and the method called add before. So those add before and add after, they are the ones who are going to increment or decrement the size variable. In this case, the only increment because we have functions that are doing the same thing, which is adding a new node. So that's why I didn't update the size here. So this is sufficient to achieve what we want to achieve. This part is also very important because you need to create the links, right? To create an empty doubly linked list. Then once you have an empty doubly linked list, then you can start adding a node to the last, right? Meaning to the back of the queue. Meaning they're gonna be placed in the same order in which we found them, which is very good. So let's look at the to array method. So the to array method, right? It's supposed to return the type T, a generic type of an array, right? So we need to create a local variable within the function because we're supposed to return something, right? So we need to create it. So I'm going to create a generic type of T, and then I'm just going to call it array. As simple as that. And then I'm just going to return the array. I'm going to return the array right before creating it, right? So that I don't forget to return the array. So to create an array, right, or to instantiate an array. To instantiate, if you remember, it means to create an instance of that class, meaning we're actually making the object, the thing that we said we're going to make. If you remember, a class is a blueprint or a plan to build something. And then the instance or the object is a manifestation of that plan, meaning we've put the plan into execution, right? Into use. We've built the thing that we've planned to build. It's like a blueprint for a house, right? When the architect, when the I think it's architects, right? When they plan to build the house, so they write the plan, they write everything, the measurements and how many windows, all those things. And then the builders come and build the object, right? So I hope you still remember the terminology. So in order to instantiate, I'm going to say is equals to new. You might be tempted, right? There's something that might tempt you a lot, which is to do this and say of type T and then pass in the size here. If you try this, it's not going to work, right? Because you cannot create a generic array of type T. So you cannot do this. So what you can do though is what? Is to say you want to create a new object instead. Because remember what we talked about, every class, if you remember when we're talking about the classes, right, in Java. Whenever you create a class, it always there's an invisible extends object statement here because Java is object oriented. It's an object oriented programming language, meaning, and it's the type of language when they created it, it was included in the plan. It's not a thing that came after the language was there. Just like C++. C++, there was C, right? Of which it had no OOP. And then beyond Strostrup, the one of the lead designers of C++, he he got an idea of taking C and then adding OOP. You see, he added OOP into C++. So that means in its nature, it it didn't take in or it didn't support OOP by default. Unlike Java, it supports OOP from the get-go. That's why even a main if even a main function needs to be within a class because everything in Java is viewed as an object. As you can see, the main function is inside a what? A class. So therefore, um, in Java, therefore, it holds true the statement that everything is an object in Java. So let's go back to dlist. So since everything inherits it inherits from the object class, in order for you to create a generic type, what you can do is, or how you should do it is you instantiate a new object because any class in Java is going to inherits that class. Then after you've instantiated the object, you cast it to a generic type of T, right? That's how you do it. So that's how it should be done. Yeah, you should cast it to a generic type because it expects to be it has to be an array. So this is how you instantiate it. So I think they're showing me warnings, unchecked, cast. Yeah, we don't have to worry about that. So there's the code. So after you've instantiated the object or the array, remember we need to create the array. So in order to create the array, the way I'm going to approach it, right, is I'm going to create what is this? A counter, right? So I'm going to create a counter, right? So let's say we have our nodes. Let's say this is our linked list, right? So this is our linked list. And in order for us to add our nodes, we need to create a node that traverses or it goes through the linked list. So we need to create what we call, just like in a for loop. Remember, in a for loop, we create int I, which allows us to go through all the indexes. With linked list, even if it's doubly or singly linked, you create a node of which you're going to use as a temporary node, which is just going to be keeping track of the pointers. So what I'm going to do is I'm going to delete this so that I can have a better view. So when you create a linked list, right? When we iterate or go through a linked list, we we create a current node or a new node which is gonna call current, and then it's going to start by pointing to this. It's gonna start by pointing at the head, and then when it points to the head, we're going to keep on updating its next, right? So that means its next is now gonna point to the first, it'll eventually go to the first node and then go to the second node. But while it's not equals to what? To null, or while it's not equals to tail. Because in our case, we have a variable that keeps track of the tail or the end. So I don't have to say while it's not equals to null. If this tail wasn't there, we have to start by initializing it, linking it to the head, and then we go to the next node, which is let's say this node the first node, then the second node, then the third node, and so forth, while we are not pointing at now. When we eventually point to now, then we know that we've reached the end. So that's how we traverse or go through a linked list. So I just noticed something here. Remember, when you go to the linked list, what we usually do is we start by linking to the head, and then while current is not equals to now, then we go to the other nodes. But then if you start at the head, I don't think it's gonna be actually useful, because if you start at the head's value is now. So that comparison is a waste of time. Even though it's just an O of one, or it's a one operation, which is just me checking if it's now, if head, which is just me comparing a head with that value that I'm currently looking for. So there's no need for us to start here. We can just start at the first node, meaning heads next, because head stores the first node, which is this first node, and is stored used inside the next variable. So I'm gonna make the current point to heads next, which in turn will just point to this node over here. So there's no need for me to waste that time. I think textbooks need to update on that, because there's actually no need for that. So you need to say node. Remember, the node class is generic, meaning that every time we create the type, we need to pass T in brackets to specify that this is a generic type or generic class. And then I'm going to make it point to my header. It's called the header, but I want to point to the next node, which is the first node. So once I have that, I can now do a while loop. So I'm going to say while my current address, remember, this is an object. Remember what we talked about? We talked about reference types and primitive types. Reference types, they're called reference types because they store references or addresses. So they know where the value where the value is stored, but they don't actually store the value itself. So that's why we're going to use a while loop to compare that while my current is not null, meaning that while I haven't reached this null, which should be the end, but then we have a tail for that. So I don't have to say while not equals to now. I can just say while not equals to trailer. Because if you go back to the constructor or the parameterless constructor, check here, everything for trailer is null. The previous, the next, or it's next, I think, next, previous, and value, they're all zero. They're all null, I mean. So that means it's all pointing to null. So while the address is not linked to trailer, which points to null, which actually keeps track of the stopping point for my linked list, then I can keep on iterating or keep on traversing. But then before I do that, I need to update my current references. So remember while loop, right? There's an update statement, because if you leave it like this, it becomes what we call an infinite loop, because current will always point to the first node, which is a problem. We need to keep on changing its address. So I need to say current and then get the next node's address by calling get next. So I update the current node, the current I update the current address that this current variable, this current object is pointing to, so that we can get this thing that I was demonstrating, that you start here and then you point here and then you point there and so forth. So while I'm not pointing to trailer, keep on going. But when I eventually get to trailer, or I point to the trailer or tail, that means I know I'm at the end, so it stops, it exits. So that's very important to understand. Then the to array, what are we actually trying to achieve here? Remember what we're trying to achieve. we're trying to get all the values in the node, and which are of which in this practical they call them elements. So we're trying to get all the elements or the values of the array of the linked list, I mean, then store them into the array in the order that we are receiving them in. In order to do that, we need to create a variable or I or int I, let's call it I, starting at 0, because remember arrays are 0 indexed. And I forgot to mention this, remember the dlist or wlist class, it has a size variable which keeps track of how many nodes are currently there. So if you delete, we need to update size. If you insert, we need to update size. Because basically size means length, meaning how many things that they are stored. But it's called size in terms of linked lists. In terms of arrays, we call it length, the array length. So don't be confused. So you don't have to think about where to get the size or how to know how many nodes are there. It's stored in the size variable. Then inside my while loop, while I'm not pointing to my trailer, meaning while I'm not at the end of the linked list, keep on doing something. So now I need it to do something. So what is this something that it's going to do? It's going to add the values into the array. How do you do that? Remember, in an array, there's only one way to set the value. You put in the array's name followed by square brackets to index, meaning to go at a specific position in the array, and then pass in the position. So where am I in the array? And then you set that position, you set it and give it a value. And this position, we can keep on updating it. Because if you remember an array, if I have an array of 1, 2, 3, 4, this is at index 0, index 1, index 2, index 3. So as you can see, in order for me to move to the next position, I need to increment by 1. As you can see, the difference in this is it's 1. How did I move from 0 to 1? I added 1. How did I move from 1 to 2? I added 1. How do I move from 2 to 3? I added 1. So that means after I've updated the value, I need to also increment I. So I'm going to show you a neat technique that you can use. So to be honest, you actually need to understand the fundamentals of coding in that language. Not necessarily the code, the concept itself, but the fundamentals. They're very important. I'll show you why. So now I need to add or insert. In this case, we're calling it inserting, right? Because at this moment, our array has zeros in it. So in my array at index I want you to, let me see. Okay. I want you to set its value to what? My current node. And look at the order of statements. You put it before getting the reference of the next node. Basically before moving to the next node. But then I don't want current because remember we talked about this node. The variable named current, it's of type node, meaning it's an object, meaning it stores references, meaning it stores addresses. That's not what I want. Because an array, you see an array is of type T, meaning that it's going to expect values, right? So I need to say current, and then I get the value of that current node. Because if you look at the node, we remember the diagram. Each node, it is an address of the previous node and an address of the next node. And it has a value of its own. And in order to get this value, we created that function, remember, called getElement. And to update its value, we have a function called setElement. So I want to get its element, so I'm going to say dot get element. And then there's my code, but we're not done. We're almost done. After doing all of this, it's up to you in what order you do it, whether you do it here after inserting into the array, or you do it after updating the reference of current. It doesn't matter. Remember, we initialize I to 0. If we leave it like this, I will always be 0. That means we're only inserting at the beginning. But we need to update our index because remember the index is the way they go. you increase by 1. So you see you move from 0 to 1 and then 1 to 2, 1 to 2 to 3, which means that they all have a difference of 1. So if I start at 0, I'm going to insert the value or get the element of that current node, the value of that current node. Then I also increase the position or the index so that the next node, the next value that I insert is going to be in the next position. So that's what I'm going to do now. And remember, you might ask yourself, what if I have less nodes than the size of my array? Well, that's impossible because the size of the array is actually the same size as the number of nodes that are there because we use the size variable that's found inside the dlist class, which keeps track of how many nodes this class currently has. Not this class, not this class, this is the wrong term. This instance or this object has. So that's why it's very easy to come up with a solution or the size because we already know it. If we didn't know the size, I would have to create a variable called size, and then within my while loop, I just keep on increasing size by 1 so that I get the size. Once I'm done getting the size, I would have to now create the array, then go through the linked lists again, and now get elements. You see that it actually takes more time if you don't know the size. That's why keeping the class, the dlist class, keeping track of the size is very important. So what I'm going to do is I'm going to update my my index here. Remember, you need to increase by 1 or increment by 1. So you can do post increment or pre-increment, it doesn't matter. At the end of the day, by the time it goes back to the condition and checks, this would have been increased by 1. So it doesn't matter in what order you do. What matters is if you do what I'm about to do right now. This can be avoided. This is an extra line of code, which is not necessary because you can increment it here like this, right? You can also do that, that's allowed. So you can increment I by 1, but then you must be very, very careful. That's why it's important to understand the fundamentals of coding in that language. What's the difference between post and pre? Remember, post increment, right? It means it has the word post in it. Post just meaning after. But after what exactly? So that means post increment, it means that it's going to increment it after getting the value or getting the current value or after getting what's currently stored in the variable. And then pre increment, it is the word pre, right? Which just means before. If you remember in English, there was prefixes and suffixes. Prefix meaning it's before the word, suffix it's after the word. If you remember those things. So pre means before. So before what? So before, no, what is this? Post just means after, okay, let me phrase it in a different way. Post means that after you've gotten the current value, then you can increment. So it increments it post, meaning after it does the increment after getting the value. Pre-increment, it's pre, meaning before getting the value, increment. So that's the important thing. If I do use the wrong one here in that line that I've highlighted, line 43, I'm going to have a serious issue because if I do, for example, pre-increment, this means before getting the value increase. So that means it's going to get the value first, which is 1, increase that by 1, which becomes, which is 0. So it's going to get that value, which is 0, increase that by 1, which becomes 1. So that means it skipped index 0 entirely. So if I have an array of these values, 1, 2, 3, 4, it will store all the values from 2 upwards, ignoring the first value, which means your output becomes incorrect. So that's why I say it's very important to understand the fundamentals. So that's why I use post increment, meaning get the value first. So it's going to replace this with the current value first, which is 0. After it has gotten the value, then it increases, it updates I to 1. So that means I get every value. So that's why I use post increment there. So you just need to be very, very careful. So far we've created the array and done. That's pretty much all we have to do. Yeah, I don't see anything else that's needed here. So we are done with this function. And then we need to perform a deep copy, right? So what is a deep copy? A deep copy, it means that you're going through all the elements and then you transfer them one by one, right? That's what we call a deep copy. A shallow copy would be just returning the address of returning, updating the addresses so that they point to the same thing. That would be what I call a shallow copy. And that's not actually a copy because the key term here is copy. That's actually linking. So we're creating a link, meaning that if I change one thing or one object's values, it affects the other object because we didn't make a copy. We created a new variable to link to the same place. So what do I mean by that? So a copy, right? Let me see how I can make this understandable or a bit more understandable. So a copy would be, for example, let's say you wanted to make a copy of or a clone, right? Let's use the word clone. You wanted to make a clone of your friend's fridge or something like that, including their food that's inside. So if you clone that fridge, that means your friend's fridge is not affected. They still have their own thing. You just made a copy and they can take that fridge and put it in their own house, right? That means you are not affected. That's what we call a copy or a clone. But if you instead only change your address, remember objects, they mimic the objects in coding or in OOP, they mimic the real world. They're still the same thing. What is an object? It's basically I would say tangible thing, anything that's tangible. For example, your laptop, the laptop that I'm using right now, it's an object. It's connected to the charger, and the charger is an object. And you as a person too are an object, but you are what I call a living object. So that's why I'm making the example of a person because it's still an object. So in that way, if you make a clone of your friend's fridge, you're gonna put your clone into your house. So clone, you can think of just someone copying you. Let's not take it too far or make it that deep that someone made a copy or a clone of your friend's fridge. Let's say you went and bought the exact same fridge that your friend bought. So that means you copied your friend. And then you bought the exact same groceries that they bought, the exact same thing. And you put them in the exact same order that they also put them in their fridge. So that means we have an exact clone of your friend's fridge. But the nice thing about a clone is that your friend is not affected. So if you eat something from your fridge, let's say you have cheese and you eat that whole slab of cheese at your friend's house, he or she still has the cheese because it's your cheese, it's not shared, right? But if you do it in a wrong way, for example, you just say delist, right? And then you say, let's say a copy, and then you just initialize it to this. Remember this, it stores the reference of the current object. So I don't want to do this. This is wrong. This is linking. That means what you're doing right now, this means you are actually moving into your friend's place, meaning that whatever changes your friend makes, they affect you. Whatever changes you make, they affect your friend. For example, if you bought juice and you guys told each other that you should share this juice, we should share, and let's say it's still closed. Then one of you guys drinks all of the juice, and your friend hasn't drank from that bottle yet. Now it's gonna be fights. So you're actually you're changing the address, because and the changing the address affects both parties because you guys are pointing to the same thing, or you stay in the same place. For example, if changing an address in the real world would be you moving into their house, you've changed your address. So when you want to maybe, for example, go do something and they tell you, please send us your proof of res, whatever, proof of where you're staying, you'd have to ask your friend to give you to get you that document. And if they ask your friend the very same thing, he or she would also get the same exact same document. So you guys are sharing an address or sharing a reference, which is not what we call a copy. This is not what you're trying to achieve. So keep that in mind. So remember, in coding, we have the stack and the heap. So let's say this is the heap, right? And let me see. What example can I make? Hmm, let me see. Yeah. So let's say you guys, one of you guys is a box, right? Maybe it's a box full of your, I don't know, let me see, a box full of your of candy or something. So you have a box, right? One of you guys has a box full of things in it. And it's at someone's address, right? One of the friends. So let's say this is one of you guys. So let me just stretch it a bit. So this is one of you guys, right? And you, you stay, it's pointing to that address, right? You know where it is, it's there. This line, that's what we call the reference. It points to that object. So if you didn't do the right thing and you didn't actually make the copy, that statement that I wrote of delist storing this keyword, remember this stores the reference of the current instance or the current object, meaning that I'm going to link. We're going to point to the same place, meaning that this will also now point here. So if your guys are staying in the same house, that means if your friend goes into this box and takes chocolate from there, it will affect the other person because you guys stay in the same place or are pointing to the object, to the same object. So really need you guys to understand the difference. So this is not going to work. So to actually create a copy, um, so I'm going to call this copied list because it's going to have it's going to store the copied list. So I'm going to actually create a new D list, a new one, because we want to make a copy. And to keep things simple, I'm going to use the parameterless one because the other one is to you to the other constructor, the constructor that we have is where it accepts an array of values, but we don't want an array, we want to make a clone. So that means I'd have to create a new D list using the parameterless constructor. So return copied list, right? We need to return it obviously once we're done. And then, if you notice something, when you start implementing, the errors go away. So don't worry about the errors, just code and then keep on saving your changes. So we have our copied list or the new list. Now we need to copy. So how are we going to copy? That's the question. So you're going to see that, yeah, you're going to see that there's this function again, add last. The function add last is going to become a very useful function in this scenario, in this class, to be honest, because I'm going to use it again now. So in order to get the last, in order to use get last or to go through the linked list, you need to create a new linked list and then make it point to the first node. You can make it point to the header, that's fine, but then I want to say that, that O of one, that useless one comparison, because if you leave it like that, it's gonna start by comparing the node, it's gonna start by comparing the current node with with head, right? Which is not necessary because head is always null. So would actually rather get the actual first node. So dot get next, the next get head as next. Head as next. Remember the head. Its goal is only to keep track of the first node. How does it keep track of the first node? It stores the address or the reference of the first node through the next variable. As you can see in the diagram, next variable stores the address of the first node, or it points to the first node. So in order to get that first node, I need to call the next. I need to get the value of next from the head. So there's a get next method of which I used. So now I can iterate and use a while loop. So while current, remember I don't have to say while not current not equals to now. We have a node that keeps track of the end. So I'm going to say while I'm not pointing to trailer, or while I'm not equal to trailer, meaning that I'm not yet at the end. I need to keep on doing something. But then if I leave it like that, it's going to become an infinite loop. So I need to update my current node to now point to the next node. So that's how you do that. Because remember we have this current node that we've created. It's going to start by pointing to head next, which points to that node. So to be honest, it's actually going to point here. Then if we leave it like that, it's going to be an infinite loop because the current node is only always pointing to the first node. So I would have to update currents next, right? It's next to keep on pointing to the next node. So how do we find this node? It's actually the current node's next method that points to there. So that's why we have that formula whereby we say the current node or the current address updated to point to the current node's next, meaning the next node. And then remember everything is done sequentially. So I need to do everything before this line. So this line is always the last line in the while loop. Because if I do this, right, what's going to happen is that I'm going to skip the first node. Because before I continue, I've already moved to the next node, which is a problem. So I need to do things sequentially in order. So what do I want to achieve here? I want to copy everything from that node into this new node. So this is simple. I'll just say copied list dot add last. I'm going to use add last again and then get the current. And to add last, I'm adding the current node. But remember, add last, it expects you to pass in the value, not the node. So I'm going to say the current node, and then I use the get element function to get the element or the value for that current node. Then after I've gotten the element or the value of the current node, I add it as the last node in the D list or in this doubly linked list. And then done. I've copied everything. Everything is done. Straightforward, no issues. Like I said, the add last method is actually, it's like it was the key thing in this practical. If you really think about it, add last was like the key thing that you needed to add there. So let's do the next functions. Let me see how much time has passed now. So 55 minutes. So what I'm going to do is I'm going to I think I should, yeah. The thing is, I need to explain everything. I need to make sure you guys really understand. So it's going to take a bit of time explaining everything, but don't stress about this week's practical. We'll go through that. We'll definitely try to make sure we go through that. If it means tomorrow we have an early morning session, it's fine. So I've add after. To be honest, linked lists are nice. They're just delicious. They're easy if you understand and you do diagrams. So I'm gonna go to my diagram again. I want to add after what? This node that's being passed. How did I know? Because there was a comment, add an element after a given node in the list. You are given the node to add after. So they tell you add after this node, add after this. So I'm going to have lm and then I'm going to have the value. So remember when you create a new node, why are they giving you a value to create the new node? Because our constructor wants us to pass in the next node, meaning what's the next node this new node is going to point to? What is the previous node that this new node is going to point to? And what is its value? So that's how the constructor works. So that's why when you have to implement add after, they give you the only the item, not the node. You have to create the new node and pass in that value. So how do we insert a new node how do you insert a new node after a node? So it's easy, right? If you have a diagram. So let me demonstrate. So let's say we have, okay, let me zoom in. So let's say we have this node. So I'm going to delete here. And then let's say this node didn't exist. This one, let me see. Okay, let me just stretch it. Let me do this. Let me select, can't I select everything here? Okay, I can't. What about if I do this and then I shift it? Yeah, let me shift it, right? And then let me stretch that a bit and then leave it here. So let's say we wanted to add node after this node. So let's say this was actually LM, because remember they've named it LM. You can rename it, that's fine. Totally fine. You can change it, that's up to you. So this is the node to add after. So I'm gonna say to add after, to make my life easier so that I know that this is the node to add after. So I'm gonna call that to add after. So to add after. Oh, it doesn't want me to copy and paste. So I'm just gonna say to add after. Basically, it's the node that I need to add after. So you don't have to worry about its next node, right? You don't have to worry about that. But then, wait. Technically, you have to, yeah, you have to worry about it. Yeah, yeah. So let's think about all the scenarios, right? That's the thing. It's important to think about the scenarios. The only messed up scenario or the bad scenario is when you want to add after the last node, because the last node's next is pointing to trailer, right? Let me see. Is it pointing to? Oh, I see. So I actually need to reevaluate the diagram. So the diagram actually works this way. Let's fix that. Let's fix the diagram because I think it's going to be very bad if you don't see the diagram. Yeah, that's the thing about tutoring. We are both learning here. So let me phrase it in a different. So this is how it works. So there's the last node, right? No, the last node is this one. So there's my tail, and remember we talked about it. The tail, everything is now. Its value, its next, its previous, they're all pointing to now. And then the last node, it is the one that's going to point to trailer. I think this is the scenario. I think this is the case. The approach they used, because if you check here, it's definitely the approach. Because if you check here, the header, since there's no node, the header points the header's next is gonna point to trailer, and then trailer's previous is gonna point to the header. So we actually have something like this. It actually makes it easier, to be honest. So its next points to tail, and then tail's previous points to the last node. So even though this one kind of looks like it's the last node, it's actually not the last node. It's just a stopping point. It's just to say before that. Just know this is the stopping point. So we don't. So now now we don't have to say now is that is the last thing. No. So I just had to fix that small issue with the diagram. So that's the difference, right? And then head is fine. So yeah. So I just needed to update the diagram a bit. So if I'm updating a diagram, and this is actually the case, things become very easy because there's no null. If there was null, I would have to check if next is not pointing to null. Or I have to check if next is pointing to null. If next is pointing to null, then I would know that I have to create the new node and then make the new node's previous point to this node that I want to add after. And I would make this and also there's gonna be a lot of changes that needed to be done. And then I would make the new node's next point to null. So let's say we have a new node, right? So maybe you might not understand when I'm just saying it. So if the new node was if this didn't exist, this structure that's here, if the last node its next only pointed to null, then it'll be a bit difficult because you need to really understand. You need to understand what you're given in order to solve the problem. So the way you are given, it's like this way. Me, I was thinking that it is actually this way, the way that I'm about to demonstrate. The new node, that means its next would have to point to null. Its previous would have to point to this node that I want to add after. The node that I want to add after its next would point to the new node. So that was the scenario that was in my head, but it's not the case. So it's actually easier. You don't have to worry about null. Your main goal is to worry about where to edit, which is, to be honest, this is an easy insertion because wherever you're adding, even if I'm adding it after, let's say this was the after node, I'd have to keep track of, I would have to find the node after the node I want to add after. I hope the English is understandable. I hope you understand what I'm saying. In order to add a node, let's make this example instead. Let's assume we want to add it right before the tail. So basically the node that I want to add after is the last node. Let's say that's the case, right? What will need to happen is I need to find this last node. You see this one over here? I'll have to find it, which is the node after the node I want to add after. Remember, this is the node you want to add after. I need to find the node after it before I do anything. So I'm going to call this node after because it's a node that's after the node that I want to add after. I hope the English is understandable. So I'm going to say node of type T. I'm going to call it node after because it's after the node I want to add after. So it's after to after node to add after because that's the node I want to add after. So that means I have to say to add after, give me its next. Because remember, next points to the next node. As you can see here, the node after the node I want to add after is found by looking at the node I want to add after is next. I have to look at its next, which points to that next node. And there's always you see why we didn't have to worry about now, because that's how the diagram was given to you guys. If this was pointing to now, then even if it was pointing to now, to be honest, it's actually fine. Yeah, either way is fine. Yeah, it's honestly, oh no, it's not fine because if this returned null like this, yeah, it's not fine. If this returned null, meaning that the diagram was, for example, in this case, like this. So we had no tail, we had no node that keeps track of the tail. We just made the next pointer null. If that was the case, that would return null. And if we go down here and try to say node after dot something, it will return a null pointer exception because you're trying to call a function on null. So that's why I say this is a better scenario. You have a good scenario. I think they thought about it before they made this practical. They were like, that would be very difficult. and then try to make it slightly easier. So now you have an easier case. So even if you have a tail, it's actually represented as its own node. So that means this statement, when I get the next node, will always return true, return something. So it returns the actual node. So this is the node after the node I want to insert after. So I have that node, meaning this is the one I want to insert after. There's the node after it. So I have this node after it. So now we need to create the new node. So how do we create the new node? We call the constructor. So I'm going to say node of type T, new node, because it's a new node, duh. And then new node of type T, and then there's the constructor. Remember the order for the constructor. You pass in next, and then previous, and then the value, right? So let me leave it like that so that we understand why I'm passing certain things or certain values. So this is the new node. It's next and it's previous. I want you guys to really understand that. The new nodes next, it's next and it's previous and its value. That's what we're supposed to pass in. So if you're looking at our diagram, its next must, let's start with previous. Its previous must now point to what? The node to add after. So it needs to point to this address, which is add after. So that means its next, it needs to point to add after. Remember, if you pass, remember what we talked about, reference types. That's why I said you need to understand your fundamentals. Reference types, if you pass the variable name for that object or for the object, you're actually passing the reference, which is the address. So that's fine, which is perfect. Because I want the address of with the node to the address of the node to add after. I want its address to be my new node's next. And then previous, no, no, it's previous. My bad, my bad. Sorry for that. It's previous, I mean. And then we still don't have the next and the value. The value is fine, it's easy. It's just this value here. So that will be the value of the new node. It's just item. Now, what is the new node's next supposed to point to? It's supposed to point to this node, which is the node that I want to add, which is the node after the node I want to add after. So it's after this node that I want to add after. So we called it node after. So this will be node after. Then I'm done. So this new node has been inserted. So this line of code in line 74, right? It has achieved this. We have this, we have that, but we still have these links over here. So I need to change the node I want to add after it's next. I need to change it to now point to this new node, and then we delete that. So let's do that. I'm gonna do one thing at a time. So which node to add after? So the node that I want to add after, I need to set. So I need to call a setter. So dot set next. Its next needs to now be updated to point to new node, right? Which is true because you see, as you can see, there's the diagram. It needs to point to the new node. So since this next has been updated, that line now disappears. But we still have this link. The node after the node that I want to add after, its previous is still pointing to the node I want to add after. So I need to fix that. So I need to take this previous node, the node after the node I want to add after, its previous should now also point to this new node. And then we've successfully inserted the new node. So let's change the node after. So the node after, we need to set its prev. We call this set prev to point to new node. And then after we've done that, the function expects you to return the new node that was added. So I need to just say return new node. And then done. It takes a bit of deep understanding of the diagrams and also understanding your code. You see, I understood everything and it didn't take me too much time to write the code. So I have to scroll down and do the exact same procedure, the same process. So I want to add before this node. So I need to get the node, right? Before, I need to get the node before. Here, remember in the previous function, we got the node after because I wanted to know the node after it so that I can change the pointers correctly. Here, I want to add the node. I want to add the node before this. So I'm going to call this one to add before. So this is the node that I need to add before. So this node that I need to add before, I need the one that's before it. So my diagram is incomplete. I keep forgetting. Previous, no. Its previous doesn't point to now. This is incorrect. It has to point to head. Yeah, I think its previous points to head. No, let me see. Let me think about it. And then set prev point to, okay, let's see. Let's look at the parameterless constructor. Let's see. I want to see the approach they chose. We're using that approach. So a parameterless constructor is basically supposed to create an empty linked list. That's why the size is 0. So empty linked list. So the empty linked list, we have the trailer, which is just everything now. That's fine. We have the header, where its next points to the yeah, its next points to what is this? Trailer. Its previous points to now, and then the value that it has is now. So with that being said, we also changed the previous for the trailer to point to head. Yeah, so we had that link. So that's fine. Mm, let me think about it. I want to think the approach they chose. I want to think about the approach they chose. So what if I insert the new node? So that, yeah, that would mean, yeah, let's go with that assumption that because that's the thing. Yeah, this would be fine. This is perfect. Because to say, I think in the previous video I talked about it, no pun intended. Previous, the previous variable should not should point to now because for you to say it points to head, that would make the first node actually not the first node. If you get what I'm saying. So previous has to point to now. So if I'm adding before, that means there's a huge possibility that the value before could be null. So if the value before, if it's null, that means I'm adding it before the first node. So there's two ways this can go about. You can add it before, you can add it, it can be added at the beginning or at the end or in between. The in between or at the end, that's fine. That's perfectly fine because this keeps track of that, right? The tail is part of the, or maybe, wait, let me see. Or maybe, yeah, let's assume, yeah, I think I'm overthinking it. I think it points to previous points to head. I think that's what it does. It points to head, but yeah, it points to head, but then head is actually it has a value of null, right? Oh no, head is yeah, okay, head is actually yeah, it's fine. I wanted to yeah, this is fine. So that I needed to update that. Previous actually points to the head, but then like I said, this is not the first node. You'd have to understand that's not the first node. So what we can do is we can check the node we want to add before, right? So let's say this is the node I wanted to add before. I need to check its previous because we want to add before. Check if it's previous. If its previous point is equal to head, then I know it's the first node, right? So, oh, let me see. Oh, no, no, no. Yeah. To be honest, it actually doesn't matter. Yeah. 100, yeah, like I said, they made it easier for you guys. It doesn't matter because I had assumed that in my diagram or the way they did it, it was supposed to be like this. No, previous actually points to head. So it doesn't matter where you insert. It's fine because it always points to something. We're just changing the references. That's all. So to be honest, it doesn't matter where you insert. You just need to understand. So at least they made it easier for you guys. So this is the node I want to insert. So if I want to add a node, if I want to add the node before, so this is to add before. So this is the node that I want to add before or behind of. So I want to add a node behind this node. So how do you go about doing it? So I need to find a node that's behind it. It has to have a node that's behind it because even the first node is a node that's behind it, which is the head, right? Even though the header, like I said, it doesn't act as an actual node, it just acts as a tracker to just track off which is the first node and which one is not the first node. It has a previous, so I need to find that previous node. So I need to do that first. So I need to create a variable of node type t, and then I'm gonna call it node before. It's the node before what node? It's before this node that I want to add before. So that means I'm gonna say add before, and I'm gonna say get prev because I want to get the previous node, meaning a node behind this node. After I've gotten the node behind or before, or the node before this node, then I can now change the pointers correctly. So let's create a new node. So a new node is equals to new node of type T, and then we pass in next, previous, and the value, right? And the value here is called item, so I don't have to stress about the value. The two things that are important is the new nodes next and the new nodes previous. So what should the new nodes previous point to? The new node, remember I'm inserting it before this. So that means it's going to be somewhere here, right? So it's going to be somewhere here. And then the head will have to shift. So the head would have to shift a bit, right? And then this, okay, I need to shift this, there we go. So this new node needs to come here, right? Somewhere here, right? So this is just an example, right? This is the new node. So its next needs to point to what? Come on. Its next needs to point to the node I want to add before. Its next, it needs to point to that. So its next needs to point to add before, right? And then its previous, the new node's previous pointer, it needs to point to the node that's behind, right? It needs to point to the node that's behind it, which is which node? Which is that node that I called node before. So that means I'm going to pass node before, and then there we go. That's everything that's needed. Are we? Are we? I can't hear you clearly. Are we? I can't hear you, but can you just mute on your side because I can't hear you. Uh, as I was saying, we inserted the new node, right? And we set the pointers and everything, but then we still need to change these pointers. So this node, its previous needs to be updated. So that node's previous no longer needs to point to that head. It now needs to point to the new node. So its previous needs to point to the new node. So I'm gonna do that and say to add before dot set, because we are setting, its previous should now point to the new node. And then the node that was before it, its next should no longer point to this node because we now have a node that's before it. So its next should now point to the new node. So I'm gonna go back here and say node before dot set its next to now point to the new node. And then after we're done, we need to return the new node. So once you're done setting the pointers and inserting the new node, you need to return it. And then, oh, before I forget, I've almost forgot. After you add a new node, right before you return it, remember we need to update its size because there's a new node that was added. So I need to increment size by 1. And then if I go down here, the node before, I need to increment size by 1 because I've inserted a new node. So the number of nodes has increased. Remember, size variable, it stores the number of nodes that are currently available. So I need to increment it every time I add something new. I need to decrement it if I remove something. So let's see. Okay, so I think we can implement search, right? I'll do remove because there's quite a lot of things that you need to do, and I don't want to waste time. I just want to like end the session now, then we'll continue tomorrow. So with the search function, we're just searching. The search function is important to understand because there's a lot that goes in. Before we continue, I forgot something here. The clone function, right? We did the clone function. And then the clone function, as you can see, there's an override annotation. That means that we've overridden this function. How did we do that? Because in order to do that, we need to implement what we call the clonable interface. So the clonable interface, as the name suggests, it's clonable. So I can open this. Okay, I can't. Why isn't it allowing me to open this declaration? But it's fine. The clonable interface, it's an interface that only has one function, which is the clone function. So you implement it and then override the clone function, then write the way you want to clone the function. But there's something very peculiar about the generic class, right? Look at the generic class. It expects some type, but then the type it expects, that type needs to extend the what? The comparable class, meaning that it needs to be a type that can be comparable. Meaning by comparable, what does that mean? It means that the t that we're gonna have, as you can see, it expects to return t. The t that we're gonna have, or the type. Remember t, they took it from the word type, hence they just say t. The t, if we say t extends comparable, we also need to pass that type t there because it's a generic type. So that means that type we expect it needs to extend or implement the comparable interface, meaning that it has what we call the compare to function. So how does the compare to function work? So the compare to function, the way it works is it returns 0, right, if the values are equal, and it returns 1 if the value on the left hand side is greater, right? And then it returns a value that's, we can say -1, but it's a value that's less than 0. So let me just phrase it this way: it returns a positive value, and here it returns a negative value. If it returns a negative value, then it returns a negative value if the value on the, not of the, on the left-hand side is less than the value on the right-hand side. This one is greater than the value on the right-hand side. So that's the function we're going to use. You might ask yourself why we're doing that. You'll understand why now. So let's try to do that. So I need to find the node. No, you see, I'm doing the wrong function. So let me take that. I need to search, right, for this node with this element and return that node. So let me format this. Let me fix this. Source format. Okay, so I need to find the function. I need to find the node. So I'm going to create a new node because I need a new node to traverse or to go through the nodes. And then this new node is going to point to my header. But then remember, we talked about it. You need to point to the first, you need to call get next so that it points to the actual first node. You'll realize that doing it this way will actually prevent errors. It's very important to understand that this will prevent a lot of errors. So calling get next or getting the actual first element or the first node is very important. Then I'm going to say, I'm going to use my while loop while current is not equals to the end, which is the trailer, because the trailer represents the end. So while I'm not at the end, but then if I leave it like that, it's going to become an infinite loop. So I need to update current by getting the next node, meaning the node that comes after the current node. And then the while loop is going to traverse properly. Then now, while I'm within the loop, right before I change my address or I change the reference to point to the next node, I have to compare and see if the current node's value, which you can get by calling get element. Because you remember in our node class, we have this, the get element function, which returns the value of the current node. So I'm gonna go back here and say current.get element. Now I've gotten the element. But then you might be tempted to do this and say if it's equals to lm, right? If it's equals to lm. You might be tempted to do that. You can do that, but that's not advisable. Okay, in this here, that's not complaining. The thing is sometimes it complains. And yeah, it complains. So I don't know why it's not complaining now, but this is generic types, right? With generic types, it means that it can accommodate any type. What if this element is actually a string? So that means I'm trying to compare references instead of actually comparing the value. So that's why we're going to use the compare to method. Because remember, get element, right, function, it returns something of type T, right? Meaning whatever type we've used. And here we've specified that this is a generic D class, and whatever type you use, it must be a type that's comparable, meaning it's a type that has the compare to function. So I'm going to use the compare to function because we are working on the assumption that the type that's being passed there, it has a compare to function. So I'm going to say dot compare to lm, right? And then I pass in the value that I want to compare to. So the thing that I was talking about, the left-hand side is equals to that, blah, blah. Okay, let me fix this. Negative value, there it is. So the thing that I was talking about, that if the positive value and blah, blah, left-hand side, which value would be on the left-hand side? This would be a value on the left-hand side. This would be a value on the right-hand side. And we're trying to look for that exact element. So that means we're gonna have to check for 0 because we're trying to look for where they are equal. So I'm gonna say is equals to 0. compare it with equals to 0 because we're looking for where the elements, the values are actually equal. If we're looking for where one value is greater than the other, then we have to use the greater than sign to check for positive values. If we're looking for where the value is less than, then we have to use the less than symbol. In this case, we're comparing to 0 because we're checking if this value is equals to that value because that's what the search function does or is expected to do. So that means we found it. So if we found it, so value has been found, then we can just simply leave the loop. Why am I leaving the loop? Because the current node that's being stored at that point in time, it's the node that we're looking for. And we break before moving on to the next node. So that means when this while loop leaves or breaks, it breaks storing the node we are looking for and stored inside current. So I can just simply return current because we found the node. And if the node was not found, we also need to handle that case. So what I would do, right? Because there's two cases we need to handle when the node is found and when the node is not found. So when the node is not found, what we need to do is, or when the node is found, we can do this. Remember, in code, you can return anyway, right? So I'm going to say return the actual current node when I found it. Else, if this loop executes and it goes down there, remember what the return statement does. When you say return a value, it actually exits the whole function. It not only exits the while loop or the loop, but also exits the whole function. So if this was found, it's going to exit the function. But for some weird reason, if it continued downward and it got here, that means we didn't find the element we're looking for. So that means I'm going to return null because that means it's non-existent. This element we're looking for does not exist. So therefore, if it manages to get there, that means the element or the node we're looking for was not found. And then here it was found. If it was found, it would just simply exit the loop and exit the loop and exit the function. So I think we can stop here and continue tomorrow. So that's it for today's tutorial. I'll send the link in the group of the recording as usual. So see you guys tomorrow.